Hello everyone, our lesson for today is about distance and displacement. So before we are going to proceed, we are going to talk about our learning targets. So one of the learning targets after the lesson is you will be able to define a reference point and then define and distinguish between a scalar and a vector quantities. You will also be able to agree with the coordinate system so we can assign different directions, if it's positive or negative, for all motions involving in one dimension. And then lastly, we'll be able to differentiate between the distance and displacement. So one of the vocabulary is the position, which is represented with x, and if it's in x coordinates. So position is just a location where an object is at a particular time. And then a reference point is a point where we use to find or describe the location of something, of an object. So in this case, this car is moving in reference to the house. It is behind the house, all right, or moving in a positive direction. But if it is in reference with the swing, it is behind the swing, so it's moving maybe negative of the swing. So that's the reference point. Right, so we're going to talk about the scalar and the vector quantity. So this indicates that all the scalars quantity are just talking with quantities that has magnitude or size, and that includes mass, temperature, speed, which is what we will be talking more in this unit, time, and then density, power, pressure, and temperature. Some of these scalar quantities may or may not have units, all right? And then another quantity is the vector quantity. This indicates that it has a scalar, which has a magnitude, but it also have a direction. An example of this is velocity, acceleration, weight, friction, and momentum. Sometimes in a higher physics class, this vector quantity is denoted with a bold text, and sometimes they are also denoted with an arrow on the top. But in our IPC class, we don't have that. So this is an example of a vector quantity. Displacement. So if you look at the stickman, he is moving to this direction, positive, and then he's moving back to where he started, so his displacement changes, right? The scalar quantity, on the other hand, because it only have the size, regardless, this is irregardless of the direction, it is always positive. So when the stickman is moving to this direction, gaining 5 meters, the direction going back is also 5 meters. So not taking the direction, we are just looking at the magnitude and giving that stickman 10 meters of total path covered. Coordinate system. So in our class, we will be able to conveniently consider which one is positive or negative. We will consider coordinate system. So we designate the north as our positive, and opposite of that is the south, and that's going to be the negative. So if east is our positive, going west is negative. One of the quantities that we will be discussing in this topic is distance, which is denoted with the letter D symbol, and this is a scalar quantities. Distance is just the length of path that any object took. It can be curvy, straight, it might be in 2 dimension, x and y, and distance always increase. Distance sometimes can be 0 when an object is not moving, but it can never be negative. Since this is a scalar quantity, it only talks about magnitude. And the unit sometimes we have with distance is meter. This is the System International that we will be using most of the time. We also have kilometer, mile, centimeter, meter. So from here, how are we going to look at the distance to solve for the total path taken? So its distance is just the A to B magnitude and then the B to C magnitude, and that gives you the distance of this two-dimensional motion path. Determining the distance traveled along the path that changes direction. So for example, if Miss Finchley walks along this diagram, so what we are going to do is we just add, if I walk 12 meter from where I start, and then I go south 8, and then I go east for 15, what's going to happen is we just add all the magnitudes. So 12 plus 8 plus 15, Miss Finchley really covered 35 meters of distance. Another example, if I walk in a different zigzag, so the same thing, we just add all the distances that I covered. In this case, it's 5 plus 10 kilometer plus 12 kilometer, and that's equivalent to 27 kilometers. So what about if I am moving in a closed path? So the distance that we will be solving here is the distance where I took from A to B, B to C, and then C to back to the original position, which is A, regardless of whatever closed path that I am taking. So suppose I traveled from that path a number of times, so the total distance will be big T, which is equal to N. N is the number of repeated time I go over that closed path, times the distance, the total path covered, and that is my total distance. Right? Determining the distance traveled along the path that changes direction. So for example, I am going along in a circle. My distance is the circumference of the circle. Right? So the same thing with the other one. My distance is the circumference of this path that I traveled. So displacement, on the other hand, is represented by delta x. This is supposed to be here, and this is a vector quantity. This is just a change in position of an object. It has a direction, so you have to remember, because it has a direction, it is always represented with a straight line between the points. So if our distance is from A to B is 1 meter, displacement is from where to start to where it ends. So since it starts here and it's going to west, then the displacement, delta x, is 1 meter. What about if it goes in the opposite direction? So the delta x displacement going east is negative, so it's going to be negative 1 meter. The symbol of displacement is delta x. Delta is just means change. That's from final minus the initial, right? From where you start, from where you end, minus where you start.